This is Algebra 1, 6.6. Guys, we're going to talk about now is systems of inequalities. So we already talked about solving systems of equations, and equations are different than inequalities. Inequalities have those symbols, as inequality symbols there, that we're going to have to remember what they are and how they're used. And we're not just going to find a single point or a bunch of points, or I guess a line a system that has infinite many solutions is the exact same line on top of itself. That we're not doing. We are actually going to find a region. Because in an inequality, when you graph an inequality, you got to graph your line still, but then you have to choose my shading left, right, or up or down. It matters which way the line is orientated. So it's going to be a region, and then eventually you will look for where do those regions overlap. So remember, we have a greater than symbol. Greater than symbols, if we're talking about a number line, is open. If we're talking about on a graph with two variables, it's a dashed line. This means it's not included. So these here, greater than, a less than symbol, these are open or dashed. They're not included. So if you want, you may even put something like that. One is for a number line, not included, dashed line, not included. The other ones down below here, or the next two, a greater than or equal to is it has the little line underneath, and then you have less than or equal to. These ones, ladies and gentlemen, are a closed dot on a number line, and it's a solid line if I graph it on a XY graph. I also, on this slide, have given you a few general guidelines on being able to graph it. Okay? So your steps for graphing these systems of inequalities. You're going to graph each inequality, separately on the same graph. Now, this itself has a couple extra steps in it, as in, I'm going to, when I go to graph this, ignore the fact that it's an inequality. I will change it in my mind to an equal sign. So I'm looking at an actual equation. We know how to graph equations. If it's in standard form, use cover-up. If it's in slope-intercept form, put the intercept and move slope, right? We've done that many times now. Now we're going to do the exact same thing. Ignore the inequality, change it to equals. And then at the end, after we've graphed that equation, step number 2 says, hey, we know we got to either be on the left side or the right side, or the top side or the bottom side here. You need to just pick a point that's not on that line, solid or dotted, and if it works, you shade that side. If it's not true, you shade the other side. Think of flipping a coin. The coin only has heads or tails, yes? If it's not heads, then it's tails. So therefore, you kind of always know what side will work. Okay? If you say, hey, heads, and I say you're right, that means it was heads. If you flip it and you say heads and you're wrong, that means it must have been tails. And then step 3, once you do this for all of your equations, and it happens to be that there's sometimes going to be more than 2 inequalities, you just look for where the regions overlap, because that's where the solutions exist. They exist in places where both equations are true. Our first example of the day here is 2x plus y is greater than or equal to 2, and 2x plus y is less than 4. So what we're going to do here is we are going to find the solutions, all the solutions to this problem. What I will do here is first I want to look at just graphing the top line, the top inequality. Now what I'm going to do in my mind is I'm going to take out that inequality symbol, and I'm just going to make it an equal sign. I'm going to act like it's an equal sign so I can graph it. And if I was to do that, I'd be like, oh, that's a line in standard form. And if it's in standard form, that means I set up my cover-up method, right? If I put a 0 in for x, that goes away. I got it covered up. So that means y has to equal 2. Put a 0 in for y, it's gone. X equals?
2.
Not 2. What does x equal? Divide both sides by 2. And what's 2 divided by 2? It's 1. Now, I'm just going to graph this one on a graph. What is the inequality symbol? What is that inequality symbol? It's a greater than or equal to. That means I'm allowed to be on this line, which means it's going to be a solid line. So maybe even after it, kind of give yourselves a heads up, and say, hey, I know this is going to be solid. So that when I go down here and I make my graph, I'm going to be able to say, I know that when I connect my intercepts, I'll be a solid line. 0, 2, and 1, 0. Is everybody okay with that? And it's going to be a solid line. Try to make it the best I can. So far we've graphed the inequality, but we have not shaded it. So I'll do basically that 3-step approach, or at least 2 steps, twice. I got to pick a point. I got to pick a point and put it in for x and y in that first equation, or inequality, to see if it's true. What point do you guys want to use? 0 what? 0, 0. Why 0, 0? Because it's the middle point. That can work. Okay. Well, first of all, can I use 0, 0? The answer is yes, because 0, 0 is not on your line. Can everybody see that 0, 0, which is here, is definitely not on that line? That means I can use it. But guess what? I can use this point over here too at, what, 3, 3? I could use 3, 3 if I wanted. I could use 100, 100, way over there. Or, let's use 1, 10. I could use any of those. But do you guys want to use big numbers? Do you guys want to use these weird decimal answers? Like, could I use 0.5, 0.5? Maybe someplace right about there? I could. I don't want to. I like 0, 0. I like 0, 0 because when I multiply things by 0, what happens? It becomes 0. So yeah, I am going to definitely put 0 and 0 in for x and y. And this is the beautiful thing about standard form. When it's in standard form, x's and y's are on the same side. So that means when I put 0 in for x and 0 in for y, this whole entire side here goes to 0. And so then you're asking yourself, is 0 greater than or equal to 2? Is that true? So that means that anything, because this point right here does not work. 0, 0 does not work. That's not true. That means this point over here is not true. The point down here at -2, -3 is not true. It means nothing on this side is going to be true. So what I do then is I shade the other side. Notice that I did not go all hog wild and shade that whole entire thing as dark as I could. I didn't because there's another line or inequality that needs to be in there and shaded as well. So be very careful on that, okay? I'll change colors for the next one. We'll move a little bit quicker here. This one's also in standard form. So I'm going to use my cover-up method. Put a 0 in for x. We cover it up. What's y? 4. Put a 0 in for y.
2.
2? Is everybody okay with that? 4 divided by 2? It's 2. So 0, 4, 1, 2, 3, 4, and 1, 2. Now, the question is, the symbol says it's a less than symbol. Does that mean it's included or not included? If it's not equal to, then it's not allowed. And so this will be a dotted line. And so when we go here and make our dotted line, where's our dotted line? Ooh, hey, both of those lines are parallel. So if this was a system of equations, there would be absolutely no solution, right? There actually still can be a solution here. I think either way we make it, there will be a solution. So here's the thing. We now have to make point and shade again. And we have to decide, are we going to shade on the left side here of the blue line, right? Or do we shade on the right side? So, picking 0, 0 again. If I put 0 and 0 into those, it becomes, and a 0 less than 4. Is that true?
Yeah.
Yes. So that means on this blue line, I will shade towards 0. Now, I didn't do a very good shading because I didn't know what was going to happen in this one. So they do overlap. That red line, the red shading, I'm going to change because the red shading should go right up to the line, right? So technically this one should be more like this. Where do they double shade? Where do they overlap? Just right between the lines. So this is where I would go back and say my darker, like, what I like to do is I just make like swirly lines so I can see it a little easier. Some people like to shade it completely. This is where I'd go back and actually heavily shade. And I would shade right down the middle there. Well, that was bad. That's a little too thick. Red and blue make purple, right? There we go. We heavily shade. Here's the thing. Any point in that shaded region will work. So when I go and ask you then, give me a point that will work. Give me a point that is a solution to this inequality system. Can we say 0, 3 is a solution? By our graph, would that be a solution? Is it in the shaded region? Yes. So then, therefore, that's a solution. What about 0, 2? Is 0, 2 a solution?
No.
Why not? It's on the side, right? But is that line solid or dotted? Solid. Solid meant included. So yes, 0, 2 is included. What about 0, 4 though? 0, 4 was on the dotted line, therefore not included. This last example, as you can see, both of the inequalities are equal to, so they're both solid. That's kind of nice. So that's solid, and the bottom one will be solid as well. One's in standard form, the other one is in slope-intercept form. So let's go right to it. Let's use the cover-up method here. Put a 0 in for x. Ooh, that's not going to be so nice, is it? What is y? If I cover that x up, what's y?
3.
It's not 3. You got to divide both sides by 6. So it ends up being 2 over 6, which is, reduce it, 1/3. Cover up y, because I put a 0 in, x equals 2. Makes it a lot easier because x would just equal 2. And we know it's a solid line. The other one's in slope-intercept form, so I think we can graph it straight from there, right? So let's make our graph. So, we know they're both solid. So 0, 0, 1/3. 0, 1/3 is approximately 1/3 of the way up. And the other point is at 2, 0. So this line has a pretty low slope, right? It's a negative slope. Is it going through 0, 0?
No.
So that means I can use it. And if I do that, is 0 plus 0 less than or equal to 2? 0 less than or equal to 2?
Yeah.
Yes, that's true. So I'm going to shade down. Okay. The other one, we'll switch to blue. Starting where?
6.
At 7. Right? Start our y-intercept at 7. Which is there. And our slope is what? Down 1 over 6. So down 1, 1, 2, 3, 4, 5, 6. Is about there?
Yep.
It's also a solid line, I think we established. Oh my. Are all of these problems always going to be parallel? These look like they're parallel. It's not always going to happen. But for our problems, it is. Yeah.
Will there be problems where you don't need to shade in them?
So, what we have is this. Now, again, I can use 0, 0. But when I use 0, 0 on this particular problem, I can't just cancel the whole entire side. I might want to write this in. Is 0 greater than or equal to 0 because 1/6 or negative 1/6 times 0 is 0.
Yes.
Plus 7. Is that true? Is 0 greater than or equal to 7? No. That means I'm not shading down here. I need to shade above. And then the question you ask yourself is, where do these overlap? They don't. So what's the solution then? No solution. There's no solution to that. So these can overlap completely. They can overlap just a little bit. Just watch where they overlap, and that's where you have to shade, or darker shade.